Hello there and welcome to my workshop. Today's video is going to be putting the electronic package together for Katie, the CNC lathe conversion. So I'm just going to quickly run through some of the items that you would need to put this together. So what you would need for a lathe is two drivers for your two stepper motors. In this case, this is NEMA 23s and they're 88 millimeter and they're 425 inch of torque, which is plenty enough for that little lathe. You'll also need, in my case I'm using Mark 3 with a USB conductivity. A lot of other earlier conversions use printer ports with 25 pin, but they're basically XPs, and this of course is a lot better method and a lot easier too. So you'll need the drivers, stepper motors, your Mark 3 card. You'll need a power supply, and in my case I'm using a 36 volt 11 amp, which is sort of a medium sized power supply. Now I am going to put all this in an old computer box, old Hewlett & Packard computer box that I've stripped out. You'll need an assortment of wiring of different colors. So what I do is when I strip a computer out, I strip the wire out of it, and I can reuse this wire again. I also have an assortment of new cable. I also have some heavy cable for the power supply to the drivers of varying different colors as well. I have a couple of connectors here that I know I'm going to use for the earths. I have some connection blocks that I sometimes use. Now when you've got all this in your box, it's very important to keep it all cool. Although there is a cooling fan on the power supply, you need to feed air to the interior of that box. So what I normally do, and don't forget I live in Australia, so it gets pretty hot here. So I have two fans, so I'm going to have one drawing air in and one sucking air out. So I have a full flow through that cabinet, which will keep the drivers cool and also the power supply. So we've got no worries there. Now in addition to that, some of the items that you will need tooling wise, a very cheap test meter, and some of the hand tools, assortment of small screwdrivers and wire strippers, cutters, pointy nose pliers. I always find a Stanley knife comes in handy too. Now in additional things that I'm going to require for this electrical part of the build is I'm going to need a 12 volt power supply. In this case this will supply 12 volt and 200 milliamps, which is a small amount, but I need them to supply these two fans, and it will do very well. You'll also need a soldering iron with small gauge solder ready fluxed, and a hatchet brush that always comes in handy, and most importantly is a power board with a built-in fusible link, and an earth. Okay, must be earthed. You're using a metal cabinet, you're dealing with metal items with 240 volt in my case. Now I'll mention this right now, as I've mentioned 240, when you receive this, now I know that all over the world there's basically two different voltages. That's 110 and 240 or 230. So the first thing you must do when you get your power supply, take it out the box and ensure that that little switch in the side is set to your region's voltage. Otherwise, as soon as you plug this in, it's going to blow it up. Okay. Last but not least, at this stage, you will need the wiring diagrams for your motors, your Mark III board, and your drivers. Now this particular one here will tell you exactly how to wire up your stepper motors and how to connect it into your drivers. Now it gets a little, the only complex part of it is what they call the dip switches, and that is setting up this driver to control the right setting to control your stepper motors. Now we'll come to that when we've wired it all up. That's the bare necessity items that's required for the electrical build for this CNC lathe conversion. But to mount it inside here, you need to mount it onto something. So I'm going to mount it onto a piece of acrylic sheet that I'm going to go over to my laser now, and well, first of all I'm going to measure it up to fit in there, and then I'll cut it out on the laser. I want 3 sections actually, one inside there, probably one on the floor, one small one at the back here, and one at the front here where I'm going to mount one of the fans. One at the back here is going to be for the plugs, which I don't have yet. I use aviation plugs, which you know, a lot of builds do use those, and I find them very efficient and very easy to use. So I might actually leave that one till tomorrow, because today is a bank holiday and everything's shut, which I forgot about in Tasmania. So but it doesn't stop me doing this build. What I intend to do is assemble everything onto the board that I'm going to cut, and then wire it up and show you exactly step by step how to wire it up, how to set the dip switches, and then test them on the bench. Okay, so during this video you're going to see a lot of these, because you know, I want to show you what I'm doing, so there's no need to see my face. Another tool that I neglected to mention is a glue gun. They come in very handy. So the first job I'm doing is, I have a power board and I'm connected to the mains and it's live, and I've put the power supply in, plugged it in, and I've cut the plug off the end. Now I'm going to do 2 things here. A, I'm going to find out whether this is working. I'm sure it is, but I don't know. And B, I'm going to check to see whether these fans are working. Now, some of these computer fans come with 3 leads. You see a white, a red, a black. You don't need the white one. That is really just an RPM register going back to the motherboard telling the motherboard how fast this is turning. And there's another type with 4 wires, much the same. You only need the red and the black. So these other pair can be dispensed with. So always keep your pieces of cable, because you never know when they might come in handy. So just to check to see if they're working, and check to see that, you know, we want them to go in the right direction too. Alright, so they should turn anti-clockwise. You see the vanes of the turbine wheel? See the shape? They actually bite in, they're shaped that way to bite into the air and pull it back. And the same with this one. Okay, so what we're going to do, just have them over the lip here so they got air to pull through. Now, I'm not sure which is positive and negative on here. Either the fans will turn the right way or the wrong way. So we'll try negative on this one. Well, that one's working, and it's moving in the right direction. So that means hopefully this one will do the same. There you go. So we know our fans are working, we know our power supply is good. So now what I'm going to show you is a very useful process as what is known as tinning the cables. Now what that is now I've stripped back the plastic with a pair of special type of trimmers, electrical cable trimmers, and I am now going to apply some solder to these to make them one strand instead of half a dozen strands. That will break off very easily. You need several hands to do this. You can be fiddly with these little wires. Okay, so we get our solder. I'll do the same for these wires too. And what I do, after cutting the wire and peeling or stripping back the insulation, I twine them together. Now I've already got this up to working temperature. And first of all, what we need to do is put a bit of solder on here. Because it's black, that's old flux. Give it a flick, make it clean, and put a bit of this is called tinning. Simple process, but I advise you to do this to all your leads. Can be a little awkward sometimes. Let's put a bit of something on there to hold it steady. And just melt the solder into the lead, and it makes a better connection. This one we can do as well. But don't stay on there too long, because you will actually melt the plastic of the lead. Okay, I'll do this one as well, but I'm going to lengthen these leads. Another important tool when you're working with electronics and electricals is electrical insulation tape. Comes in very useful. So really what I'm doing with this is sealing this up, this joint. One wrap around there, then put the two together. Of course this is DC voltage, 12 volt, and you know, it wouldn't hurt you at all, but electrically you want it sealed, which that is. Now the next job is to get our piece that we just cut on the laser. Now the quickest and easiest method to attach this to this acrylic, make sure I've got it the right way around, the way I want it, and that's that way. I want it to pull air in through. Okay, as you get your glue gun, put a little bit on each corner like this. Get rid of those strands. And that's all it requires. It really doesn't require a screw. And then if I move that out the way, bring this in, and I'll just alter the camera slightly. Now we're going to get our fan and we're going to place it into here. Fit it in. And if you cut it right on your laser, it will fit in there perfectly. And get your glue gun again, just in the corners, because if you ever have to take it out for whatever reason, you can. And that's it. Because just inside here, oh, it always pays to have an assortment of very small 3mm, I suppose, 2.5mm or 1/8 of an inch screws and nuts. You can get these at any hardware store, and also these connection blocks you can get at a hardware store too. So I'm just going to pick up on this slotted hole right here, put a nut on the inside. So having connected that up, there's my connection block. So there's the front fan. This is the extended wires to the rear fan that I've attached on there. And you can also use your glue gun to secure your cables along inside here. It's a very simple method. I've used it over the years on a lot of projects and it works, and it's safe. And it's you know, not the end of the world. You can actually disconnect it, then it will just hold it there for a moment or two, and it keeps it up out of the way, and it saves using zip ties all over the place. I use this method for this sort of low voltage application. I'd like to give a big shout out to my patrons who make this possible, and the rest of you for watching. Thank you very much, and if you've liked the video and it's been a help to you, please press like and subscribe to my channel. That's a really good thing to do. And on my channel you'll see things like this, CNC conversions, wood turning, CNC routing, CNC milling, and laser machine operation as well, and the associated programs with all those tooling. So thank you for joining me, and it's bye for now.